Hello, my name is John. In the last video we machined the acme thread on this shaft, which is going to be the new Z-axis feed screw for the milling machine. Today I'm going to machine this end down to size for 2 bearings and put some threads on the end. It's a metric thread and I'm using an imperial lathe, so I'll have to use a compound gear to cut the metric thread. I've got the shaft mounted between centres. I'm going to machine this end here, so I'm going to have to use a fixed steady to give this end some decent support. This is the fixed steady. It's a thing that normally lies rusting in the bottom of lots of lathes. The steady locates on the bed of the lathe, locates on the V at the back and the flat at the front. When I machined the shaft, I left a register on for a bearing. I also left it enough room so I get the fingers of the steady on to support it. It's locked in place. There's a flat plate at the bottom and a nut on the top. Open it up. These fingers are adjustable. Top locks down. That finger's adjustable as well. Lubrication is important. All I use is a bit of ordinary bearing grease. It'll take a lot. That locks down. Lock the nuts on the fingers, screw them into the touch. Get a feel for it, feel them. The bars between the centres, so it's centralised anyway. Start the lathe running. You can hear them start to touch and feel them. You need to make sure they're not too tight, but they've got to give support. You nip it up. Feels nice. I've just made a classic mistake. I've set all this up. The carriage is on the wrong side of it. I suppose I can use a file. We'll let it do it again. If it's running, you've got to keep an eye on it to make sure it doesn't get too warm. A little bit of oil always helps. If we loosen off the centre, you feel it's gripping just nice, but not too tight. Just enough support. This is the tool I'll be using. It's a right hand tool, it's a tip tool. This tool does probably 80% of all turning work. Facing. I know it's on centre height because I use it all the time. Before you power the lathe up, make sure you can get the travel you need all the way up to the shoulder. Nothing's going to catch, nothing's going to foul anywhere. Turn the lathe up by hand. Getting the size now, there's 25 out to come off it. I'll slow this feed rate of the lathe down. It's like cut 5 outside and then again. It's easy to take it off, you can't put it back on. When you can, it's not easy. Size again. It's the same size at both ends, which is good. And it's 15 thou to come off. I'll take a 5 thou cut, 5 thou side, that's 10 thou. And measure it again. It's easy to take it off. You can't put it back on. Well, you can put it back on, but it's not easy. Right, we had 15 to go. I took a 5 thou cut, 10. So now we need another 5 thou. I'm going to take another cut without adjusting the tool, just to take any spring out of it. You always get spring. It'll probably take 2-3 thou off. So if I dial in a 5 thou cut, it would take probably 7 thou off. It would be too small. Crew it on your size nice and gently. Don't rush it. There's a lot of work on into this shaft. There's a few hours of work on into this shaft. I don't want to mess it up now. I'd rather take 3 or 4 cuts and crew up on the size gradually. Just try and hit it spot on. Once I get to within a thou of it, I'll finish it off with empty tape. Right. Still got 4 thou to go. We're getting near, very near. Right. It's 1 thou, just under 1 thou of the size I want. I'm going to finish the face off by hand. Lock the carriage up. Tight cut. Just bring it out by hand. But I'm going to finish it off by polishing. I'll start off with 220 emery. There's a lot of controversy about. There's a lot of controversy about using emery tape on a lathe. You've got to be careful. You don't use a bit a foot long so it wraps around the shaft, it'll pull your hands off. What I do, I use a piece that'll go roughly halfway around the bar. There's no way that's going to wrap around itself and pull my hand in. Obviously you make sure your sleeves aren't hanging loose, the shaft's just turning slow. That being said, the lathe has a lot of torque. We'll start away in. I'm not doing this to get it finished, the finish is perfectly acceptable. What I'm trying to do is take that last half a thou of it, get it down to size. One thing you need to watch for when you're polishing, things start to get warm. When they get warm they get bigger. Not a lot bigger, but we're talking about a bearing fit here. Right, the shaft's cooled down, had the water on it. It's right where I want it to be. Right, I need some threads on the end. The thread length's 620 thou. I've got a parting tool on centre height, it's touching the end of the bar. 0 compound slide. Right. Wind that out. I wind my compound slide in. 1, 2, 3, 4, 5, 6. That's 600. That's 6 thousandths. Plus 10, 20. Now measure. Yep. We need to cut a recess for the threading tool to end up in. I'm going to use a parting tool for this. The parting tool must be set on centre height or very slightly below. Lathe running at a reasonable speed. Set it away and see what happens. See with a cross slide. Once it starts to cut, keep it going, don't back it off. What a lot of people do is when it starts to make a noise, they back off. Don't back off, wind it in. Don't be frightened of it. I've got a nice groove for the threading tool to finish off in. Nice chamfer on them. Just by hand. Looks better, it's actually stronger as well. Good chamfer on this end. It's the end of the shaft, ready to take the thread. The thread's actually 20mm by 1.5mm pitch. You see I've got a nice chamfer on the end. Pitch of threads. You use a thread gauge to measure the pitch. These are thread gauges. They've got various sizes on them. These are metric. I know it's a metric thread. This is the thread we need on the end of the shaft we've made. 1.5 gauge, and you can see it fits in the threads. That's it there. It fits in spot on. So we know it's a 1.5mm pitch. We know it's 20mm diameter. I've actually got a nut I can try on to make sure the thread is correct. Right, gears have got numbers wrote on them. 24. I know it's a 24. That goes on the top. That's your stud gear. Wash it back on. Put a 20 tooth on the bottom. It's just a spacer, doesn't do anything. That's it. This gear's a 56. That's the gear you want on the bottom of there. I've got a chart that tells you. Right. Put them with the right on. So we've got a 24 on the top, 56 on the bottom. This all slides around. Put them in the mesh. You've got to be careful the gears aren't too tight. Need a bit of backlash in them. I say it's important that the gears have backlash in them. If the gears have no backlash, they'll start to bend up. See what works. That's your gear ratio there between that one and that one. That's your conversion from pure to metric. The top two gears, that's what they call a tumbler reverse. That reverses the direction of the lead screw or cutting the left or right hand thread. This goes to a gearbox which feeds the lead screw. The gearbox has got various settings for various threads, and I have a chart which shows me what to set this to cut the 1.5 to the inch thread. I'll set it in the power. Just stuff I use. Chain loop, messy, but it does the job. Take it on. The chart says to put the 1.5mm pitch and set the gearbox up at 16 threads to the inch. Move this one along. 14, 15, that's 16. There, 16. And it says that this one is in position B, which is that one. So we've got the gearbox set up to cut 16 threads to the inch. But in the back of the lathe we've put our conversion gear in place, so now it'll cut 1.5mm pitch. Once again, it's very important that the tool is on centre height, which it is. This was set up for the Acme screw cutting tip, which is obviously the same make a tip as this, so it's that's on centre height. Once again, this being a foam tool, I'm going to cut the thread straight in. I'm not going to offset the compound at an angle. Edge of the tool square. End of the shaft square. Check it. To cut this thread, it's a metric thread imperial lathe. I'm not going to use I won't be using the dial indicator. Instead I'll be reversing the lathe. I will not disengage the feed nuts once the thread's started. I'll turn the tool in, just touching, zero the cross slide. We've checked the gearbox is set in the right position, the lead screws turning in the right direction, the lathe's in slow speed, back gear. And start it up, run nice and slow. So we're at zero, a touch of feed, right, away it goes. Procedure is stop the lathe, zero your counter, wind it back one full turn. Reverse the lathe. Stop the lathe in one full turn plus your depth of cut, 5,000. All it's done is barely mark the surface of the metal. So now we've got a 1.5mm pitch screw gauge. We'll check the pitch. Spot on. So we can cut the thread. A little bit of oil. Now our nuts are engaged, so as soon as I start the lathe, the carriage will go forward. Once again, zero, out one full turn. Reverse the lathe. Stop, in one full turn, 5,000 cut. I'd be able to see better from this angle. Start the lathe, cutting nice, and I can slow it down just as it clears the end. Stop. Zero your cross slide, out one full turn, lathe backwards. Stop, in one full turn, plus your feed, 5,000. Lathe forward. all but. That's interesting. And disengage the feed nut now, the thread's done. I'd just like to show you this. Wonder of Chinese engineering. My threads are straight. That's a nut. That is absolutely amazing, that. The guy that made that must have been pissed. I mean, how would you expect that to tighten into a bearing and hold the flange square to a bearing? It's so annoying. The gears, some of the gears good, and things like this spoil it. There's no excuse for that. There's no quality control there at all. I think I'll be making some of them as well. Well, that about wraps it up. The next video I'll be machining the keyway in the end of the shaft, and I'll have a go at making a nut.